All right, let's jump right in and talk about one of the most fundamental and honestly, most powerful features in all of Azure networking, virtual network peering. If you've spent any time at all in the cloud, you have absolutely faced the exact problem we're about to solve.
So, you're building out your world in Azure. You've got your applications, your databases, your services, and you've put each one in its own secure virtual network, or VNet. It's all nice and tidy. But how do you actually get them to talk to each other?
And that's the thing, right? By design, they can't. These VNets are completely isolated from one another. You can think of them like secure digital islands. Now, this is fantastic for security, but it becomes a real headache the moment you need a service from Island A to communicate with Island B.
And that is exactly where VNet peering comes in. It is this beautiful, elegant solution that builds a secure, private bridge between those islands. It lets two or even hundreds of VNets communicate as if they were all part of the same single network. And the best part? All of this happens on the private Microsoft backbone.
So how does this magic bridge actually get built? Well, let's break down the two main types of peering and get into why this is so important for your cloud architecture.
It's actually really simple. You have two main flavors. First, there's local peering. This connects VNets that live within the exact same Azure region. Like East US to East US. And then you have global peering, which, you guessed it, connects VNets across different regions, say from the US all the way over to West Europe. The underlying tech is the same. The only real difference is geography. And the benefits here are huge. We're talking about a low-latency, high-bandwidth connection that makes it feel like all your resources are right next to each other. All the traffic stays private on the Microsoft backbone, so it never has to touch the public internet. That means you don't need to mess with complex gateways or extra encryption. You can even peer across different subscriptions and different company tenants. And get this, there is zero downtime to set it up. Plus, there's a newer feature called subnet peering that gives you even more granular control.
Okay, so that covers the basics. Let's move on to the more advanced stuff and see how this feature lets you build some truly powerful network architectures.
This is where peering goes from being simple connectivity to being real network architecture. It's a concept called service chaining. It lets you force traffic from one VNet to go through a virtual appliance, like a firewall, that lives in a completely different peered VNet. And you control all this using something called user-defined routes, or UDRs.
So let's just walk through that. Imagine some traffic is leaving a virtual machine in what we'll call a spoke network. Now, instead of going directly to its destination, that UDR kicks in and redirects it. The route basically says, hey, your next hop is the IP address of that firewall appliance over in our central hub network. The traffic gets inspected by the firewall, and only then is it allowed to continue on its way.
And just like that, you've got the foundation of the most popular network design in Azure, the hub and spoke model. It's an incredibly efficient and scalable design. You have one central hub VNet with all your shared services, firewalls, gateways, you name it, and all your other spoke VNets just peer to it.
Another awesome capability here is managing your IP address space. As your company grows, you're going to need to add, modify, or even remove IP address ranges from your VNets. With peering, you can do all of this without any downtime. Once you make the changes, the peered networks just need to sync the peering link to recognize the new space. It's really that simple.
Now, what about connecting all this back to your on-premises data center? Let's take a look at how peering works with gateways to create that seamless hybrid cloud environment we're all after.
This feature is called Gateway Transit, and it is a game changer. It's a setting on the peering connection that lets a spoke VNet, which doesn't have its own gateway, transit through the hub VNet to use its gateway. This gives that spoke VNet access to your on-premises network through the hub's VPN or ExpressRoute connection. Now, this is the crucial rule you have to remember. A virtual network can only have one gateway, period. You can't have a VPN gateway in your spoke VNet and also try to use a remote gateway in the hub. Gateway Transit is the feature that lets you officially designate the hub's gateway as the remote gateway for all the spokes.
And why does this matter so much? It all comes down to cost and simplicity. Instead of deploying and paying for a separate gateway in every single one of your VNets, you deploy just one in the hub. You manage it in one place, you pay for it in one place, and all your spoke VNets get to use it. It's a huge operational win.
All right, before we wrap up, let's cover the really practical stuff. The limits, the constraints, and the pricing model you need to be aware of.
So out of the box, a single virtual network can be peered with up to 500 other virtual networks. I mean, for most use cases, that is a massive number and way more than enough.
But if you're working at a massive enterprise scale, you can use a service called Azure Virtual Network Manager to double that limit, letting you peer a single VNet with up to 1,000 others. This lets you build enormous hub and spoke or even full mesh topologies.
Now, there are a few specific constraints to keep in mind, especially for global peering. Resources in one VNet can't communicate with the front-end IP of a basic SKU load balancer in a globally peered VNet. It's a technical limitation, but a really critical one for architects to know when designing cross-region solutions.
So how is all this priced? Well, the peering link itself is free to set up, but you are charged for the data moving across it. As you can see, there's a nominal fee per gigabyte for both ingress, that's data coming in, and egress, that's data going out.
And here's a super important detail on pricing. When you use Gateway Transit, that traffic from the Spoke network is still billed as peering traffic. The charge is applied to the Spoke VNet, the one without the gateway, which is really crucial to remember for accurate cost forecasting.
Which brings us to our final question, the one for you to think about. Now that you understand how VNet peering connects your isolated networks, enables these powerful hub and spoke models, and simplifies hybrid connectivity, how could you use it to redesign and streamline your own cloud architecture?